Welcome to video podcast 3, Orthogonal Views. I'm William Herring from Albert Einstein Medical Center in Philadelphia. Orthogonal views are two views that are obtained at right angles to each other, and they are necessary in order for us to be able to localize an object using conventional radiography. When we X-ray a patient's chest, for example, in the frontal or lateral projection, everything from the skin on the patient's back through the lungs, the spine, the heart, and the skin on the patient's front is superimposed on each other on the X-ray cassette. If there's a lesion in one of these layers, then when we look at the X-ray image, it may be difficult to tell where, from front to back or side to side, that lesion is located. If we look at three hypothetical patients, the horizontal gray lines here represent the X-ray cassettes, and the blue structures are the X-ray tubes. We're looking down on the patient's head. Patient A has a lesion on the anterior chest wall, and it projects there on their film. Patient B has a lesion that's inside the chest. It projects in the same position on their X-ray film, and patient C has a lesion posteriorly in the skin on the back, and it projects in the same location. So clearly it would be difficult to tell from just one view where this lesion was located, and so we'll add another view at 90 degrees to the first, an orthogonal view represented by the vertical gray stripes. And in the case of patient A, we can see that the lesion is projected in that location on the X-ray cassette. Patient B, it's projected in that location, and patient C, it's projected in a different location. Now, if we take the two pair of images, the frontal and lateral, for patient A, for B, and for C, and we look at them together, as we usually do, it is relatively easy to localize where the lesion is. Now, this isn't as important as it may once have been, because we now have imaging techniques that use cross-sectional imaging, such as CT or ultrasound or MRI. And here's a patient who has a CT scan of the chest, and we can see quite easily that they have a nodule that is in the left upper lobe. There's no question that this is in the left upper lobe. It's not on the skin on the front or the back. It is in the lung. But that's not always possible to make that determination initially. And here's a case in which a patient has a metallic foreign body. Once again, it is a bullet, but we can't tell from this frontal projection alone whether the bullet is in the skin, subcutaneous tissue in the front or the back, or it's somewhere in between. And so, as you've already guessed, we get a lateral view, and on the lateral view, we can clearly see that the bullet is inside of the chest. And now we have two views at 90 degrees to each other, which localize to the bullet to the inside of the chest, to the lungs. And this bullet actually is in the aorto-pulmonary window, so the patient is very lucky to have survived. Here's another example using bone. So this is a frontal view of the femur, and we can see that there is a dense calcification that is superimposed on the distal femur. This calcification could be cortical, it could be intramedullary, or conceivably it could project outside of the femur. And so if we get another view at 90 degrees to the first, an orthogonal view, we can now see that the dense amorphous calcification lies within the intramedullary cavity on the orthogonal view, and therefore, since it is in the intramedullary cavity on both views, it represents, in this case, an old bone infarct. one of the causes of medullary calcification. So this is your turn. You could put your computer or iPod on pause and take a look at this chest X-ray and decide what the next study is the best to get. Well, hopefully you were able to see a nodule in the left upper lobe of this patient, or at least superimposed on the left upper lobe of this patient, and hopefully you said that the next image that you would obtain would be a lateral view, which is a close-up we're showing you of a lateral here. And if you look very carefully, there is a lesion that is projecting outside of the chest on the patient's skin on the lateral view. This actually represented a mole on the patient's skin. So it was very important to obtain two views at 90 degrees to each other to demonstrate, not only by physical examination, but also by the X-ray, that this is a lesion that's outside of the chest. So to recap, orthogonal views are two views that are taken at right angles to each other. They are key to localizing objects on conventional radiography.